Hello, and welcome back to College Algebra, MAT 150. In this lecture, we're going to look at some rational inequality examples. So, how do we find, or how do we deal with inequalities? Well, we're looking for intervals. Okay, so interval is written in interval notation. So the moment you see an inequality, you should be thinking, hey, I need a number line. And so how do we find how to partition the number line? We'll look at the factors, and the factors in the divisor as well. So in the numerator and denominator. So we have 3 as a factor. We have x as a factor. And we have x plus 6 as a factor. We set them all equal to 0. Now, 3 can never be 0. Okay, it's just a number that never equals 0. So again, you don't really need to set numeric factors equal to 0 because it's just never true. But anything with a variable you can. So we have x equals 0, and we subtract 6 from both sides, and we have x equals negative 6. So again, this is not the calculation for our final answer. It is just to help us split the interval. And our interval is split up with negative 6 and 0. And now we need to test to see which interval or which intervals work. So between negative infinity and negative 6, again, pick something overwhelming. Between negative 6 and 0, let's pick negative 1. These are test values, and then a number to the right of 100, or to the right of 0, excuse me, pick something like 100. And we're going to look at each of these factors. So even though we didn't set it equal to 0, and it won't be useful particularly here, again, we're trying to see if the whole thing is positive or negative. So it still matters as a factor. 3x and x plus 6. We're just trying to see if all that multiplies or divides to be our answer, or to be, in this case, greater than 0, which is positive. And because this is being divided, we're going to call the full thing Q for quotient. And the values we're going to test, we've already sort of put up there. Negative 100, negative 1, and 100. And we make this table. And we're just going to test each value. So 3, no matter what x is, so again, these are the x values here. So no matter what we plug in for that, it's always going to be positive 3. Negative for x is just negative, negative, positive. Negative 100 plus 6 is negative. Negative 1 plus 6 is positive 5. 100 plus 6 is positive, and now we see if everything multiplies or divides to be positive. Again, we don't have to actually think about what the original function was. We can just think about it as multiplication, because multiplication of negatives, the rules for negatives for multiplication are the same for division. And we have positive, negative, negative is positive. Positive, negative, positive is negative. Positive, positive, positive is positive. And we want the stuff that's positive, so let's just indicate what's positive and negative. Positive, negative, positive. We want the positive stuff, so let's shade here and shade here. And again, we have a strict inequality, and we're dividing in this case. Negative 6 would make the whole thing 0, so it's always undefined at 0, so that's always going to get parentheses. And then x equals 0 makes the whole fraction 0, so it gets parentheses because, again, it's a strict inequality. So our final solution set is negative infinity up to negative 6, union, and then 0 to infinity. And this is our final answer. Now, again, the only thing that feels different is the fact that we're dividing, but notice how we treat it basically exactly the same. The only time where this will feel different is if there's an equal sign there, possibly. And so we're going to look at the exact same example where there is an equal, and we're just going to copy down basically because we've done all the hard work. We just need to see how it would be different in this situation. So we had negative 6, 0, And we're looking for when it's positive, greater than or equal to 0, positive or 0. So we have this, positive, negative, positive. And we've already tested all these values. The only difference is here at -6, this is when the denominator was 0. So no matter what, when we're filling these out, even though there's a inclusive inequality, here we're going to have a parentheses for the -6 in the denominator. Again, you can't divide by 0, so we never actually have -6 included here. But that means that, because of this inclusive inequality, the whole thing can equal 0, basically when 0 is in the numerator. So here we're going to actually have brackets. All right, so what is our answer? Our final solution set is now given by -infinity to -6 with parentheses union 0 to infinity, where 0 gets a bracket, because we actually can include 0 in this one. And this is our final solution set for this one. So this is the only way that it differs really from this problem up here. All right, that concludes this lecture and this section.